An object from another star system is blazing through our own, and it's putting on a show that has astronomers scrambling. This isn't just another rock, it's an interstellar messenger that's rewriting the rules as it gets closer to our sun, glowing 6 times brighter than anyone predicted. What is fueling this incredible outburst, and what secrets from a distant star does it carry? Let's explore this together. The numbers don't lie. So what do we actually know about this visitor? Let's break down the hard data. Right now, the interstellar comet designated 3I Atlas is roughly 2 astronomical units from the Sun. That's double the distance between the Earth and our star, about 300 million kilometers. Its speed is almost difficult to comprehend. It's currently traveling at nearly 60 kilometers per second and is still accelerating. By the time it makes its closest approach to the Sun, that velocity will peak near 68 kilometers per second. To put that in perspective, that's more than twice the speed of any planet, and fast enough to travel from the Earth to the Moon in a little over an hour. On the brightness scale, 3I Atlas has reached an apparent magnitude of 12. While that's about 250 times too faint for the naked eye, its brightness has been climbing far more rapidly than any models predicted. Its coma, the cloud of gas and dust surrounding the nucleus, has expanded explosively, now rivaling the diameter of Jupiter. While a typical comet nucleus is only a few kilometers across, this expanding atmosphere is what makes it so visible. The sheer scale of this coma is a key reason why it's appearing so much brighter than expected. The unexpected brightness surge. Why is this object causing such a stir? It all comes down to a sudden, dramatic change. In September, 3I Atlas experienced a massive surge in brightness that defied all expectations. The light curve, which is the chart astronomers use to track an object's brightness over time, shot sharply upwards, veering completely off the predicted path. This wasn't a minor increase. The object is now glowing 6 times brighter than models had forecast, a jump of nearly 2 full magnitudes. This jolt sent a wave of excitement and debate through the astronomy community, with experts like Matthew Knight, a specialist in cometary outbursts, analyzing the data. The core of this mystery lies in its coma, the vast cloud of gas and dust that surrounds its nucleus. As the comet gets closer to the Sun, its ices are vaporizing at an accelerated rate, causing the coma to swell to an enormous size, now spanning several 100,000 kilometers. This giant cloud is reflecting and scattering more sunlight back towards us, making the entire object appear far brighter in our telescopes. The rapid brightening suggests that highly volatile ices like frozen carbon monoxide or carbon dioxide, which vaporize farther from the Sun than water ice, are driving the activity. Racing against the Sun's glare. For astronomers on Earth, the clock is ticking. By early October, the window to observe 3I Atlas is closing, and fast. Every evening the comet appears lower in the twilight sky, getting progressively closer to the blinding glare of the Sun. The angle between the comet and the Sun, what astronomers call solar elongation, will shrink below 30 degrees by October 21st. That's the critical threshold where even the world's most powerful ground-based telescopes, like the Very Large Telescope in Chile, can no longer distinguish the comet's faint glow from the overwhelming brightness of the sky. Amateur astronomy networks are in a frenzy, trying to capture the last possible images before the blackout. Professional observatories, bound by strict safety protocols to protect their sensitive equipment, have already begun to scale back their observations. Pointing a multi-million-dollar telescope too close to the Sun is a risk few are willing to take, as it can permanently damage the sensitive optics. This data blackout is happening just as the comet is expected to reach its most active and interesting phase, leaving a huge gap in our understanding. Mars, the last outpost. Just as Earth's view is about to be lost, the observational challenge shifts 225 million kilometers away to Mars. For a short but critical window, the red planet becomes the only outpost with a front-row seat. A fleet of robotic orbiters will become our eyes and ears. The European Space Agency's Mars Express can capture high-resolution images and chemical fingerprints of the coma. The ExoMars Trace Gas Orbiter is designed to sniff out faint traces of gases like water and carbon dioxide, giving us clues to its composition. NASA's MAVEN, led by principal investigator Bruce Jakosky, can use its ultraviolet spectrograph to study emissions from the comet's gas and dust, while the Mars Reconnaissance Orbiter could potentially resolve the nucleus itself with its powerful HiRISE camera. which can see features as small as 1 foot across from an altitude of 300 kilometers. On October 3rd, 3I Atlas will pass within 28 million kilometers of Mars, close enough for detailed study, but far enough to avoid any danger to the spacecraft. This encounter is our last, best chance to gather close-range data before the comet disappears from view. The green mystery. One of the most captivating features of 3I Atlas is its stunning green glow. What's causing this otherworldly color? Spectral analysis points directly to a molecule called diatomic carbon, or C2. Here's how it works. As the comet gets pummeled by solar radiation, the sunlight breaks apart larger carbon-rich parent molecules on the surface through a process called photodissociation. This process excites the resulting C2 molecules, and as they relax back to a lower energy state, they release photons of light specifically in the green part of the spectrum, primarily in what are known as the swan bands around 510 nanometers. This phenomenon is seen in many comets, but the intensity of the green hue in 3I Atlas is exceptional. The work of Nobel laureate Gerhard Hertzberg, who pioneered the study of molecular spectroscopy, provides the foundation for understanding these emissions. This color is a real-time indicator of how rapidly the comet's surface is changing and shedding material as it barrels towards the sun. The impossible anti-tail. As if a green glow wasn't strange enough, some observers have reported something even more bizarre, a faint feature pointing towards the sun. This is a so-called anti-tail, and it appears to defy the laws of physics. We normally expect a comet's tail to be pushed away from the sun by solar wind and radiation pressure, a phenomenon seen in famous comets like Comet Arend-Roland. However, the unique geometry of this encounter combined with the comet's incredible speed creates a different phenomenon. As 3I Atlas ejects larger dust grains, those particles are less affected by solar pressure and tend to remain in the comet's orbital plane. From Earth's perspective, as we cross that plane, some of this dust can appear to project towards the sun, creating a sunward spike. The late Michael A. Hearn, a leading expert in cometary dust, developed models to explain these complex dynamics, showing how electromagnetic forces can sometimes rival gravity's influence on charged dust particles. While reports of the anti-tail are still tentative, its presence would add another layer of intrigue to this already mysterious visitor. Not like the others. So, to truly understand just how unusual 3I Atlas is, we have to compare it to the only other interstellar visitors we've ever seen. The first, one Oumuamua, discovered back in 2017, was a bizarre, cigar-shaped object with a high orbital eccentricity of 1.20 and, no visible coma or tail at all. It was basically a dry, inert shard just tumbling through our solar system. Then 2 years later, 2I Borisov arrived, and it looked way more like a classic comet, with an even higher eccentricity of 3.3. It had a bright coma, a well-defined dust tail, and a chemical makeup that was pretty similar to comets from our own Oort cloud. But 3I Atlas just refuses to fit into either of these boxes. Its coma is not only massive but also intensely green, which is a sign of strong diatomic carbon emission, something we just haven't seen with this kind of intensity in Borisov. And its dramatic brightness surge, a 6-fold increase above predictions, is unlike anything we've seen with the other two. According to University of Hawaii astronomer Karen Meach, this diversity really shows we have much to learn about the small body populations of other star systems. The Mars encounter strategy. The hopes of the entire astronomical community now rest on a handful of spacecraft orbiting Mars. Mission planners have spent weeks preparing for the October 3rd flyby, running simulations and allocating precious observation time. The goal is to get a multifaceted snapshot of the comet that would be impossible from Earth. Scientists want to use the high-resolution cameras like MRO's HiRISE, which has a 0.5-meter primary mirror, to try and spot the nucleus and measure its size and shape. Spectrometers will analyze the light from the coma to map the chemical composition of its gas and dust, telling us what kind of alien ices are vaporizing off its surface. Plasma instruments will study the interaction between the comet's atmosphere and the solar wind. No single spacecraft can do it all, and none have promised continuous coverage, but by combining data transmitted through the Deep Space Network, scientists hope to piece together a comprehensive profile of this interstellar visitor. It's a difficult observation, but the potential payoff is a groundbreaking understanding of a body from another star system. chemistry in motion. Let's dive deeper into the chemistry that makes 3I Atlas so fascinating. The dominant green glow comes from diatomic carbon C2, but it's not the only molecule at play. Some early spectral readings have hinted at the presence of ionized carbon monoxide and the cyanogen radical, both of which can also contribute to a green or blue glow. Debates have already started in scientific forums about the precise mix of these chemicals, often relying on data from powerful spectrographs like the X-shooter instrument on the VLT, which can cover wavelengths from the ultraviolet to the near-infrared in a single shot. The comet's incredible speed is a key factor here. It means that solar radiation is stripping away fresh, pristine ices from the nucleus at an astonishing rate. We are not just seeing ancient processed material from the surface. We are likely getting a look at the primordial parent molecules that were frozen inside this object when it formed billions of years ago in a completely different planetary system. This makes 3I Atlas a unique chemical laboratory. The fade begins. What happens after 3I Atlas swings around the sun? Its brief moment of glory will be over and the fade will likely begin. Most models predict a sharp drop in brightness as the comet speeds away from the sun's heat, its vibrant coma shrinking and dispersing back into the void. For anyone hoping to catch a final glimpse, it will be a challenge. A large telescope with at least a 20-centimeter mirror will be the absolute minimum, and even then, it will likely appear as just a faint, fuzzy smudge. This is where citizen science will take over. Amateur astronomers and online networks similar to the American Association of Variable Star Observers will pool their observations, using techniques like image stacking to track the comet's retreat. These platforms provide real-time updates on its position and brightness, creating a light curve that professional astronomers will use to understand its behavior. The story doesn't end when it gets dim. Studying the post-perihelion light curve can reveal crucial details about the comet's structural integrity and whether it survived its fiery passage intact. The journey of 3I Atlas through our solar system, though brief, leaves us with more questions than answers. Each data point gathered from this mysterious visitor helps us understand the diversity of objects that wander the galaxy. What does its unique composition tell us about the planetary system where it was born? How many more of these interstellar travelers are out there waiting to be discovered? As it slips back into the darkness, 3I Atlas reminds us that our solar system is not an island, but part of a vast, interconnected cosmos. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Thank you for watching Sci and Why.